Good day, good day, good day. Welcome back to our YouTube channel. So if you're new here, welcome. My name is Stifler and I hope you are going to have a great time here. So please just rush to subscribe to our channel so that we'll keep on creating content for you that you're going to enjoy and that you're going to benefit a lot from. So today we are on algebraic expressions grade 10. So to understand algebraic expressions, obviously we have to start with numbers so that we understand all the numbers that we have. In grade 10, we are going to deal mostly with real numbers. So firstly, let's talk about numbers in general so that you understand the whole system of numbers. So obviously in numbers, so this is our whole number system. So this is the whole number system that we have in all of the maths. We have all this number system. So number systems are divided into two groups. These groups we have undefined numbers. We have undefined numbers and we also have complex numbers. So undefined numbers, obviously, they are numbers that we don't have answers to. Just for example, if we are dividing any number by 0. So any number that is divided by 0 becomes undefined. So these numbers, we cannot define them. So these are undefined numbers. And from undefined numbers, we also have complex numbers. So complex numbers, they have non-real numbers. So these are non-real numbers and we also have real numbers. So real numbers are the ones that you are interested mostly in. So in non-real numbers, we have also some things that cannot be defined as well. Mostly if you are having a square root of a negative value. So this cannot be defined as well, but they fall under non-real numbers. So these are non-real numbers. So real numbers are all the types of numbers that can be defined. So that's where we are interested in from grade 10. We are mostly interested in this. But also you have to understand what are undefined numbers and also what are non-real numbers. So let's focus on real numbers now and let's talk more about real numbers. So let's take a look at real numbers since we are interested mostly about real numbers. So real numbers are subdivided as well into rational and irrational numbers. So rational numbers are anything that you can place as a fraction, a over b, when a is a whole number and also b is a whole number that is not 0, right? And irrational numbers, we cannot express irrational numbers as a over b. So this cannot happen in irrational numbers. Things like pi. Pi is 3,142 and so on and so on. It continues. It's a long number, right? It has a lot of digits. And also surds. Surds fall under irrational numbers. If we're having a square root of 5, we cannot express a square root of 5 as a fraction. So it falls under irrational. And also, if we're having all the non-recurring decimals, so if we're having the decimals that are continuing with different values or different digits, we cannot express them as a rational number, as a fraction, so it's irrational. So this falls under irrational values, right? So we are going to talk again more about surds, right? And this, we are also going to talk about them on the next section and this. So talking about rational numbers. So in rational numbers, we have integers. So what are integers? Integers are all negative and positive numbers, including 0. So we are moving from negative infinity to positive infinity. These are whole numbers. For an example, we can have negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. These are called integers. Whole numbers from negative infinity to positive infinity, they fall under integers. And integers are part of rational numbers because we can express this as a over b. For an example, we can have 3, negative 3. This negative 3 is the same as over 1. So it can be expressed as a fraction as a over b. And we have also fractions on their own. So fractions already they are in this form, a over b. Just for an example, if we're having 2 over 3. 2 over 3 is a fraction and it can be expressed like that. So it's rational. And we also have recurring decimals. So if you're having decimals that are having something that is recurring, that is continuing, that is coming back again, over and over again, right? We can express this as a fraction. The how part, we are going to see how. I'm going to explain how you can express these recurring decimals into a fraction. So this can be 0.7, like this. So if you see something like this, it means that this value is recurring over and over again. This means recurring, or they can also express it as, and they can put 3 dots like that. It means and so on. It is continuing in that way. So it means that this, we can express it as 0.7777 and so on. It is continuing like that. Those are called recurring decimals. Or you can also have something like 0.89 when 8 and 9 are recurring. So this is the same as 0.898989, continuing like that. And we also have whole numbers. So whole numbers are all positive values starting from 0. So these are whole numbers. These are whole numbers. They are falling under integers. And also under integers, we have natural numbers. So natural numbers are more like whole numbers, but now they exclude a 0 now. So this goes up until forever, right? So these are natural numbers. Whole numbers, they're falling under integers. And integers, they're falling under rational, because we can express them as a fraction. And also fractions, they're rational and also recurring decimals. So mostly, we are going to be talking about how to express this as a fraction. And we are also going to be talking about surds, how you can deal with surds and to know between which 2 integers does these surds lie. And we're also going to talk about non-terminating or non-recurring decimals, mostly in rounding off. So we mostly want to round off this to 2 to 3 to 1 decimal place. But according to CAPS, because we're studying CAPS right now, CAPS, we have to put everything into decimal places. So we are going to express this to 2 decimal places. Let's just get straight to it without wasting further time. So let's learn about changing a recurring decimal into a fraction using these simple steps. So step 1, make sure repeating digits are immediately after the comma. So that's your first step. You must make sure that your repeating digits must be exactly after the comma. If not, multiply or divide by 10, 100 or 1000 to make digits recurring be immediately after the comma. So if your digit that is repeating is 2 steps away from the comma, it means that we are multiplying by 100. And if it is 1 step, we are multiplying by 10. If it is 3 steps away, we are multiplying by 1000, and so on, right? You are going to see when we are doing examples here. So also, your first expression must be x. So whatever that you are given, you must call it x. And when you multiply or divide by 10 or so, you must call it 10x now, because you have multiplied by 10. So that your expression must be equal on the left-hand side and also on the right-hand side. So if 2 digits are repeating, multiply by 100. If only 1, multiply by 10. If 3 are repeating, multiply by 1000. So now, since you have made your first equation and your second equation, now we can subtract equation 1 from equation 2 to give you sort of an equation. And from then we are going to solve for the value of x. So now we are going to solve for x. So let's use simple examples to show you how you can work this to change a recurring decimal into a fraction. So I'm having 6 questions that I will solve. So firstly, let's start with 0.7 recurring. So 0.7, this is equivalent to 0.777 and so on. So it is continuing. So we can see that this 7 that is recurring is immediately after the comma. Can you see that? It is immediately after the comma. So we can proceed. So we can let your x being equals to 0.777 and so on. So now, how many digits are repeating? It's only 1. This 7 is the only one that is repeating over and over again. So I said if you are having 1 digit that is repeating, you multiply by a 10. So we are going to multiply this equation by 10. So this we can call it equation number 1. So if we multiply by 10, it means that this becomes 10x, and this will move 1 digit this side. So this will become 7.777 and so on. So this can be our equation 2. So now you're having two equations now. So what's next? We have to subtract your equations. So equation 2 minus equation 1, like we said there. We subtract your equations so that we solve for the value of x. So now it means that your 10x minus x becomes 7.777 minus 0.777. So now your 9x becomes this, subtracting that, it will just give you 7. So now we solve for x, or x, divided by 9, So divide by 9. So now 9 and 9 can cancel. So x becomes 7 over 9. So it means that therefore your 0.7 recurring is equivalent to 7 over 9, like that. Can you see how simple this is? Yes. So it means that we have changed a recurring decimal into a fraction. So let's take a look at the second one. So now let's look at the next question that we are having. So 0.13 recurring. So we know that this is equivalent to 0.131313 and so on, because it is recurring. So you have to make sure that your digits that are recurring are immediately after the comma, and yes, they are immediately after the comma. So now what's the next thing? Now you make your equation be equals to x. So you can say let your x be equals to 0.131313 and so on. So now we are having two digits that are recurring. So two digits recurring will multiply by 100. So we are going to multiply this whole equation by 100. So it means that x multiplied by 100 becomes 100x. And this multiplied by 100, this becomes, so two digits will move that side. So this will be 13.131313 and so on. So now this is your equation 1, this is your equation 2. So now we have to subtract equation 1 from equation 2. So 2 minus 1. So now 100x minus x, this gives us 99x. And 13.13 minus that gives us just 13. So now divide by 99, divide by 99. So x becomes 13 over 99. So which means that 0.13 that is recurring is equivalent to 13 over 99, like that. So let's move on to the third question. Now let's look at this. So we're having 0.72, but the 2 is recurring. So this is equivalent to 0.7222 and so on. But now our repeating digits or our recurring digits are not immediately after the comma. So what do we do now? So firstly, let's let our x be equals to 0.7222. So now since we are having our digits that are recurring not immediately after the comma, and we're having one digit after the comma, can you see that? That is not recurring. So it means that we can multiply by a 10 to make this move one step that side. So if we multiply by 10, it means that this becomes 10x being equals to 7.2222 and so on. So now when it is like this now, just because we're having our first digit after the comma, the digit that is recurring, it is immediately after the comma. Now we can call this our equation 1. So now let's see. So this is immediately after the comma, and how many digits are recurring? Only one digit is recurring, it is 2. So if you're having one digit that is recurring, you multiply by a 10. So again, we are going to multiply again by a 10. So this will give us 10x multiplied by 10, this is 100x. And this multiplied by 10, this will just give us 72.2222 and so on. So this will be our equation number 2. So now we're having equation 2 and equation 1, we can subtract the 2. So equation 2 minus equation 1, then 100x minus 10, this gives us 90x. And 72 minus 7 gives us 65. And then this will cancel each other out, right? So now we can divide both sides by 90. We can divide both sides by 90. So 90 will cancel that 90 out. And here it is 65 over 90, and you can further simplify that, because we're having a common factor which is 5. You can divide both terms by 5. So this gives you 13 over 18, like that. So it means that your 0.72 that is recurring, it is equivalent to 13 over 18. As simple as that. Let's move on to the next. So let's take a look at 1.2 and 4 is recurring. So we can write this as 1.2444 and so on, right? So we can let our x be equals to 1.2444 and so on. Now let's take a look at our value of that is immediately after the comma. So this value is not recurring. So it means that we must multiply by 10, since it's only one digit that is not part of the recurring digits, so that it can move one digit that side, right? So we can multiply by a 10. So it means that this becomes 10x being equivalent to 12.444 and so on. So we can call that equation 1 now, since our first digit recurring is immediately after the comma. So now, how many digits do we have that are recurring? It's only 1. Only 4 is recurring. So we are going to multiply by 10. So we are going to multiply this by 10 as well, and this will be 100x being equivalent to, so this will move the side, so 124.444 and so on, and you can call that equation 2. So the next step now, it is to subtract equation number 2 minus equation number 1. So 2 minus 1. So 100x minus 10x will give us 90x. And 124 minus 12 is 112. And these will cancel each other out. So we can divide throughout by 90 by 90. So 90 and 90 will cancel each other out. So x becomes 112 over 90, which you can also divide further. 2 can get onto these two numbers, and this will be 56 over 45. So which means that your 1.24 recurring is equivalent to 56 over 45, just like that. So let's move to a bit of complex numbers. So let's take a look at 5.291 recurring. So this is equivalent to 5.2919191, because 9 and 1 are the ones that are recurring. So now we can let our x being equivalent to 5.2919191. So we check, is our digits that are recurring immediately after the comma? The answer is no. We are having this digit that is recurring, that is not recurring, and it's immediately after the comma. So it's only one digit, so we can multiply by 10. So if we multiply by 10, it means that your 10x now can become 52.919191, and so on. So now we can call this equation 1. So now we take a look at the digits that are recurring. How many digits are recurring? It's 2 digits. 9 and 1 are recurring. So it means that if there are 2 digits repeating, we multiply by what? By 100. So we are going to multiply by 100 as well. So it means that our 10x multiplied by 100, this gives us 1000x. Being equals to, if we multiply by 1000, 2 digits by 100, 2 digits will move that side. So this becomes 5291.9191, and so on. And you can call that equation 2. So now we can subtract the two equations. Equation 2 minus equation 1. So 1000x minus a 10x, that will give us 990x. And 5291 subtracting 52, this gives us 5239. And these will cancel each other out. So we can divide both sides by 990, like that. So our x becomes 5239 over 990. So it means that our 5.291 recurring is equivalent to 5239 over 990. So now I hope you are able to change your recurring decimal into a fraction. So before ending this video, I'll also leave the work that you can try to do on your own, and I also leave the notes in the description. So in the description there'll be our Google Drive, so you can check out the work there, and you can also check out the notes there. So let's move to sets. Since I said we are also going to be talking about sets, mostly about how you can identify between which two integers does your set lie. So let's talk about sets. What are sets now? So sets are numbers under the square root that are not perfect squares. So what are perfect squares? So perfect squares, just for an example, if we're having 1 times 1, this gives us 1. It's a perfect square. 2 times 2 gives us 4. So these are perfect squares. 3 multiplied by 3, that's 9, and it's a perfect square. 4 multiplied by 4 is 16. 5 multiplied by 5, it's 25. 6 multiplied by 6, 36. 7 multiplied by 7, it's 49. You get the idea, right? So these are perfect squares. So if we're having numbers that are not perfect square, for example, square root of 5, it's a SED. So this is a SED. It cannot be rationalized, right? So what do we do now, or what questions you can be asked based on this? They can ask you between which two integers that does square root of 5 lie. So you just have to ask yourself, you are having a 5, so 5 lies between which two perfect squares? So 5 is between 4 and 9, you can see that. So it is between 4 and 9. So it means that it lies between 4 and 9. So root of 9, root of 5, and root of 9. Can you see that? So now root of 4, it is known, it is 2. So this is not known, it is 5, and this is root of 9, which is 3. So it means that root of 5 lies between 2 and 3. These are integers where this lies. We can also try maybe root of 29. So where does root of 29 lie? You ask yourself, where does 29 lie between there? So 29 lies between 25, so we have 29 there, and 36. So we can put a root there. So 25 gives us 5, and this doesn't give us a square root, and this gives us 6. So root of 29 lies between 5 and 6. So root of 29 lies between these two integers. That's where it lies. So I'll also leave out the work on this so that you can try also on your own. So let's just rush to rounding off so that you can round off to 2 decimal places. So we have been doing rounding off since primary, so I won't talk much about rounding off to 2 decimal places. But what you need to know is, whenever you are doing your calculations, always round off at your final answer. So in caps, we round off to 2 decimal places. So it means that we only need 2 digits after the comma. So now what do? You check your third value. If your third digit here is greater or equals to 5, then that will affect your second digit. It will move up. So since this is greater than 5, so it means that it will cause this to move up to be 4. So this will be just 1.24, like that. So let's apply the same thing here. So let's look at our third value. Our third value is less than 5. So this can never change that to be the next value. So this value will remain the same as 3.29. It won't change. So if it is less than 5, this won't change. But if it is greater than 5, then this will change. So this is rounding off to 2 decimal places. So I'll leave checkpoint 1 and checkpoint 2 for you to try on, to try to work on that. I hope to see you on the next one, and I also hope you enjoyed this session with me. Please don't forget to subscribe and also click that like button, right? Have a lovely day. I'll see you on the next one.
It's the beat that make it turn up on your ex, make it turn around and flex, make it fly in the jets. Ayy, it's the beat that make it do it for a check, make it do it for the net. How you moving in your neck? Ayy, like an X-Men, you can get X'd out. I remember telling Noah we the next.